Dear students, today we will study one of the important chapters of mathematics that we mainly deal with probability. It is one of the major branches of mathematics. It is mainly coincided with our statistics. You might have studied it in the first year, a small portion. All those portions are needed to continue in the second year. So, we will start with the first year itself. So, our chapter is probability theory and the subheading is conditional probability. Okay, first of all, let us find out what are the important words or definitions of probability. The first one is random experiment. See, a random experiment is an experiment which can be repeated a number of times, but each time the result is unpredictable. It is random experiment. For example, tossing a coin, throwing a die. We are not sure about head or tail when a coin is tossed, and similarly when a die is thrown, we are not sure about which number will appear on the face turned up. So these are known as random experiment. Now let us come to sample space. The second one is sample space. The set of all possible outcomes of a random experiment is known as sample space, and we write it in set notation, and sample space is usually denoted by S. In the first example, look at this. S is equal to set H comma T. H stands for head and T for tail. And when you write S in the second case, that is in the case of throwing a die, it is set 1, 2, 3, 4, 5, 6. Okay, I think you have got some idea. Now next is event. What is event? That is very important. One of the important definitions of this one is event. That is, any subset of a sample space is called an event. See, in this example, the experiment tossing a coin, sample space contain two elements, that is H and T. We usually call as sample points. H is a sample point and similarly T is a sample point. The subsets are as follows. Look at the one. First one is set H, then set T, then third one set HT, then fourth one, it is our empty set. So there are four subsets. Look at this. Have a look at this. All these are subsets of S, and we call all these are events. So events are very important when you deal with probability. Now let us come to types of events. First one, that is simple event or elementary event. What is an elementary event? An event having only one sample point. That means only one element. That is known as simple event or elementary event. Second one is compound event. If an event containing more than one sample point, we will say it is a compound event. Then third one, sure event and impossible event. These two terms are very important. So what is sure event? An event which is sure to occur is called a sure event. An event which is never to occur is called an impossible event. Suppose you consider the random experiment of throwing a die. Then we know the sample space 1, 2, 3, 4, 5, 6. And suppose a person is throwing a die and he is expecting a number greater than 6. We cannot get such a number. So we say it is an impossible event. And similarly, suppose a person throwing a die and he expects a number less than or equal to 6. Then it is always possible. So we call it as sure event. Now you consider another two events. Say capital A getting a prime number, then capital B getting an even number. In the experiment of throwing a die. In roster form, we can represent them as like this. Capital A is equal to set 2, 3, 5 and capital B 2, 4, 6. See, look at their prime and these are even numbers. These two events are compound events since they contain more than one sample point. So, compound event always contains more than one sample point. Now let us come to another important definition, that is mutually exclusive events. This is very important. Mutually exclusive events. When will you say two events are mutually exclusive? Two events, capital A and B, are said to be mutually exclusive if the occurrence of one event excludes the occurrence of the other. See, give the importance to this one. That is, one of the event excludes the occurrence of the other. Let us consider an example. Look at this. That is a random experiment associated with our throwing a die. It is S is set 1, 2, 3, 4, 5, 6, and we define two events on S. One is E1, that is getting an odd number. Another one E2, getting an even number. Then in roster form, you know E1 is set 1, 3, 5 and E2 is set 2, 4, 6. E1 and E2 are mutually exclusive. They cannot occur together. That is the importance of mutually exclusive. If E1 occurs, then it excludes the occurrence of E2. Otherwise, if A2 occurs, then it excludes the occurrence of E1. So, they are known as mutually exclusive. And another important thing you can notice there is E1 intersection E2 is always null set. It is very important. When you say about two mutually exclusive events, you remember this. E1 intersection E2 is always null set. If A and B are another two events, if they are mutually exclusive, then also A1 intersection A2 or A intersection B must be null set. And in the first example, we have considered A and B. Look at this. That is, these are also two events associated with the experiment of throwing a die. Here capital A is set 2, 3, 5 and capital B is set 2, 4, 6. It is A is getting a prime number and B is getting an even number. What about the intersection of A and B here? It is not a null set. You know, the intersection contains a common element, it is 2. So, what about A and B? So, A and B are not mutually exclusive since their intersection is not equal to null set. Okay, do you get the idea? Mutually exclusive. Now we come to equally likely events. Equally likely events. Events are said to be equally likely if there is no reason for an event to occur in preference to any other event. When an unbiased die is rolled, then all the elementary events are equally likely. Or in simple words, we can say each one get equal chance. When a die is thrown, there are 6 outcomes. All outcomes are equally likely. That is the reason. The main point is there is no reason for an event to occur in preference to any other event. This is equally likely events. Okay, let us come to another definition. That is complement of an event. What is complement of an event? If you consider an event associated with a sample space S, it may be throwing a die or tossing a coin. Then another event B is said to be the complement of A if B is equal to S minus A. So when will you say B is the complement of A? We can say B is the complement of A only if B is equal to S minus A, and it is nothing but our A dash in set theory. You might have studied it in set theory. That is A dash. That is the complement of S set. Here in set theory we usually represent U as universal set. Here it is replaced by S. So in probability, for universal set, instead of universal set, we use always sample spaces. So we can say B is equal to A dash or A dash is equal to S minus A. Let us consider the following example. Look at this. Let us consider S is equal to set 1, 2, 3, 4, 5, 6. When we write S is equal to set 1, 2, 3, 4, 5, 6, it is understood that the random experiment is throwing a die, and it is very clear. Now you define two events A and B as follows. See, capital A is getting a number less than 5 and capital B is getting a number greater than or equal to 5. These two are two events. Here A and B are complement to each other, so we can replace B by A dash. Thus we get, look at this, A is set 1, 2, 3, 4. That is a number less than 5. So we can take only 1 to 4. That is 1, 2, 3, 4. Then what about A dash? A dash is the remaining elements. They are 5 and 6. Right? Look at this. A is set 1, 2, 3, 4 and A dash is 5, 6. Note here A union A dash. What is A union A dash? When you take the union A and A dash, you get the entire set or it is the sample space. And similarly, when you take intersection, that is A intersection A dash, it is clear that there is no common element, so it is null set. So in that case, we can say 5, 6 is the complement of set 1, 2, 3, 4. And it is usually denoted as A dash. S is a sample space, stands for universal set. And if you represent the universal set in probability theory, it is usually represented by a rectangle and written by capital S. Hey dear friends, now let us come to the most important part of probability, that is probability of an event and what is its mathematical formula. Okay, let us see how is probability of an event is defined. Probability is always associated with an event. Remember that probability is always connected with event. If there is event, there is probability. If there is no event, there is no probability. Look at this. Let S is a sample space associated with a random experiment and capital A is an event defined on S. So there should be always a sample space and there should be always a subset. Subset means an event. Then the probability of the event, and it is usually denoted as P of A. How is it defined? Look at this. P of A is equal to N of A divided by N of S. You have studied in set theory. What is N of A? That is the number of elements in A. And similarly, what is N of S? The number of elements in S. So what it says, P of A is N of A divided by N of S. Actually, probability is only a ratio. Look at this, N of A by N of S. Or in words, you can say probability of A is equal to the number of favorable outcomes to A and divided by the total number of outcomes in S. The number of favorable outcomes of A, what does it mean? So event may change. When event change, the outcomes may change. In the example, if you consider throwing a die, 1, 2, 3, 4, 6, that are the outcomes. And if you consider A as the define the capital A as getting an even number, then you know A contains 3 elements. They are 2, 4, 6. So what is the probability of A? Then the probability of A is 3 divided by total number of outcomes in S. That is S. That is 6. So it is 3 by 6 and its value is 1 by 2. Now another important thing is this one. And we know that A is always a subset of S. And we know N of A, that is number of elements in A, must be always less than or equal to N of S. That means the number of elements of A cannot exceed number of elements in S, since A is only a subset of S. So suppose N of A is M and N of S is N, then P of A. How will you define P of A? Then P of A will be M divided by N, that is the number of elements of A divided by number of elements in S. And it is clear that the maximum value of NA is N and minimum value is 0. Because S is a superset of A, so the A can go to maximum value N. So let us find out another result, that is 0 less than or equal to M less than or equal to N. So that means the maximum value of M is N, it cannot exceed N. So M lies always between 0 and N, including 0 and N. So now you divide throughout using N, then 0 by N less than or equal to M by N less than or equal to N by N. That is 0 less than or equal to P of A less than or equal to 1. This is the most important thing you have to remember. That means probability of any event does not exceed 1 and it does not go below 0. That means probability cannot be negative. If in examination, if you get an answer greater than 1, then your answer will be wrong. Why? Because probability cannot exceed 1. The maximum value of probability is 1 and minimum value is 0. So there should not be any negative value. So let us remember the following points. Look at this. Probability of event cannot exceed 1. In other words, the minimum value of probability is 0 and maximum value is 1. Now there are some questions you have to think yourself. First question, when does the probability of an event equals 1? Question number 2, when do the probability of event becomes 0? And third one, give examples for sure event and impossible event in throwing a die. Okay, now let us come to some important results which we have already studied in the first year. Results, first one. The first one is addition theorem, P of A union B. It is P of A plus P of B minus P of A intersection B. Second one, the particular case, that is if A and B are mutually exclusive. If A and B are mutually exclusive. Then we know that probability of A intersection B is 0 because A intersection B is null set. That A and B are mutually exclusive. Then the above formula reduces to P of A union B is equal to P of A plus P of B. Then third one, it is probability of A union A dash, where A dash is the complement of A. Then you know that A intersection A dash is null set and they are mutually exclusive, so we can write P of A union A dash is equal to P of A plus P of A dash. And A union A dash is equal to S, because A is a subset of S and A dash is the complement of A. So we get S is equal to A union A dash. Then what about the probability of A union A dash? Probability of A union A dash is equal to probability of S. Got it? And we know that P of A union A dash is P of A plus P of A dash. So we will write which implies P of A plus P of A dash is equal to P of S. Then what about P of S? That is, S is a sample space. So P of S is sure event, and what is its value? So, but P of S is equal to 1. Therefore, P of A plus P of A dash is equal to 1. That is the total probability. The probability of an event and its complement is always 1, equal to 1. Remember that, is very important. Probability of an event plus probability of its complement is equal to 1. That is the total probability. So from this we can write P of A is equal to 1 minus P of A dash, and P of A dash is 1 minus P of A. Then these three results are same. We are rearranging it. P of A is equal to 1 minus P of A dash, and P of A dash is 1 minus P of A. Now let us come to the main topic, that is conditional probability. This is the section that we have to study in the second year. What is conditional probability? We will start with an example. You consider the random experiment of throwing a die. Then what is its sample space? S is equal to set 1, 2, 3, 4, 5. than 6. Okay, now let us define two events A and B on S such that A is equal to set 2, 3, 5, that is getting a prime. Getting a prime number, and another event B is equal to set 2, 4, 6, that is getting an even number. Now we define the conditional probability, that is, what is the probability of A if B is happened? That is the question. That is known as conditional probability. We denote it like this. Probability of A given that B has occurred, then what is its probability? When we write P of A given B, it is understood that B has already happened. Then what is the probability of A? Then how will you find out the probability? Usually we find out the probability number of favorable outcomes divided by number of outcomes in the sample space. For example, if you write P of A, what is P of A? See, A contains 3 elements and S contains 6 elements. So, a probability of A is 3 divided by 6 and it is 1 by 2. Then what is probability of B? B also contains the same number of elements, that is 2, 4, 6. So, its probability is again 3 by 6 and it is 1 by 2. Now the question is, what is the probability of A if B has occurred? Then we can forget about S. That is the importance here. Here we deal with only B. It is given that B has already occurred. What does it mean? So our sample space reduces to the form 2, 4, 6. So B contains only 3 elements, and out of this, which element is favorable to A? That is the question. Probability of A given B. You look at this, in B there is only one element which is favorable to A, that is 2. So the probability you can write directly as 1 divided by 3. Look at this. Our sample space AC is reduced to 2, 4, 6. That means as B contains only 3 elements. Out of these 3 elements, only one element is favorable to A. So the probability of A given B is 1 by 3. This you can apply in entrance examination. You can directly write the answer. But in CBSE question, it may not be like that. We have to apply the formula. Now let us check what is it. Look at this. What is A intersection B? That is set 2. Look at this. A is set 2, 3, 5 and B is set 2, 4, 6. Then A intersection B is 2. So what is the probability of A intersection B? Probability of A intersection B is equal to A intersection B contains only one element and S contains 6 elements. So what is the probability of A intersection B? It is 1 by 6. That is, the number of favorable outcomes to A intersection B is only 1 and there are 6. So P of A intersection B is 1 by 6. Now let us calculate what is P of A intersection B divided by P of B. It is 1 by 6 divided by, what is P of B? P of B is here, it is 3 by 6. You take 3 by 6 and you got the answer as 1 by 3. Look at this, equation 1 and equation 2. From 1, we have directly written the value, that is 1 by 3. By observing B alone, you can immediately write the answer. But in the second case, we apply a formula, that is P of A intersection B divided by B is 1 by 3. Now, this is the formula for P of A intersection B, and we write finally as probability of A given B This is read as probability of A given B. That is conditional probability. The meaning is B okay. If so, what is the probability of A? So P of A given B is equal to P of A intersection B divided by P of B